Hey everyone, welcome to the Lit in Space podcast. This is Alessio, partner and CTO in residence at Decibel Partners, and I'm joined by my co-host Zoox, founder of Small AI.
Hey, and today we're in the studio with my good friend and former landlord, Will Bryk.
Roommate. How you doing?
Will, you're now CEO, co-founder of Exa.ai, used to be Metaphor Systems. What's your background, your story?
Yeah, sure. So, I'm CEO of Exa. I've been doing it for 3 years. I guess I've always been interested in search, whether I knew it or not. Like, since I was a kid, I've always been interested in, like, high-quality information. And, even in high school, wanted to improve the way we get information from news. And then in college, built a mini search engine. And then with Exa, it's kind of like fulfilling the dream of actually being able to solve all the information needs I wanted as a kid. I guess I would say my entire life has kind of been rotating around this problem, which is pretty cool.
Yeah. What do you enter YC with?
We entered YC with, we are better than Google. Like Google 2.0.
Yeah. What makes you say that? Like, that's so audacious to come out the box with.
Yeah. So you have to remember the time. This was summer 2021, and GPT-3 had come out. Like, here was this magical thing that you could talk to, you could enter a whole paragraph, and it understands what you mean, understands the subtlety of your language. And then there was Google, which felt like it hadn't changed in a decade, because it really hadn't. And you would give it a simple query, like, I don't know, shirts without stripes, and it would give you a bunch of results for the shirts with stripes. And so, Google could barely understand you, GPT-3 could. And the theory was, what if you could make a search engine that actually understood you? What if you could apply the insights from LLMs to a search engine? And it's really been the same idea ever since, and we're actually a lot closer now to doing that. Yeah.
Did you have any trouble making people believe? Obviously, there's a Sam Altman YC overlap. Was YC pretty AI forward, even 2021, or?
It's nothing like it is today, but there were a few AI companies, but we were definitely bold, and I think VCs generally like boldness, and we definitely had some AI background, and we had a working demo, so there was evidence that we could build something that was going to work. But yeah, I think the fundamentals were there. I think people at the time were talking about how Google was failing in a lot of ways, and so there was a bit of conversation about it. But AI was not a big thing at the time.
Yeah. Before we jump into Exa, any fun background stories? I know you interned at SpaceX. Any Elon stories? I know you were at Zoox as well. Kind of like robotics at Harvard. Any stuff that you saw early that you thought was going to get solved that maybe it's not solved today?
Oh, yeah. I mean, lots of things like that. I never really learned how to drive because I believed Elon that self-driving cars would happen. It did happen, and I take them every night to get home, but it took 10 more years than I thought.
Do you still not know how to drive?
I know how to drive now. Okay, I learned it 2 years ago.
That would have been great to
I was obsessed with Elon. Yeah. I mean, I worked at SpaceX because I really just wanted to work at one of his companies. And I remember they had a rule, interns cannot touch Elon. And that rule actually influenced my action.
Is it
but can Elon touch interns? Ooh.
Like physically or
physically,
talk?
Physically,
okay.
Yeah.
Interesting.
He's changed a lot, but his companies are amazing.
What if you beat him at Diablo 4,
Oh, maybe. Yeah.
Yeah, I want to jump into Exa. I know there's a lot of backstory. It used to be called Metaphor System. So, you've always been kind of like a prominent company, maybe at least RAI circles in SF.
I'm actually curious how Metaphor got its initial aura. Mm-hmm. You launched with very little.
We launched very little.
There was this big splash image of this is Aurora or something, right? And then I was like, okay, what this thing? The vibes are good, but I don't know what it is. And I think it was much more sort of maybe consumer facing than what you are today. Would you say that's true?
No, it's always been about building a better search algorithm, the vision has always been perfect search, and if you do that, we will figure out the downstream use cases later. It started on this fundamental belief that you could have perfect search over the web, and we could talk about what that means. And the initial thing we released was really just our first search engine, trying to get it out there. Kind of when OpenAI released ChatGPT, they didn't. I don't know how much of a game plan they had. They kind of just wanted to get something out there.
Low-key research preview.
Yeah, exactly. And it kind of morphed from a research company to a product company at that point. And I think similarly for us, we started as a research endeavor with clear eyes that if we succeed, it will be a massive business to make out of it. And that's kind of basically what happened. I think there are actually a lot of parallels between Exa and OpenAI. I often say we're the OpenAI of search because we're a research company, we're a research startup that does fundamental research into making AGI for search in a way. And then we have all these like business products that come out of that.
Interesting. I want to ask a little bit more about Metaphor side, and then we can go full Exa. When I first met you, which was really funny because like literally I stayed in your house in a very historic Hayes Valley place. You said you were building sort of like link prediction foundation model. And I think there's still a lot of foundation model work within Exa today. But what does that even mean? I cannot be the only person confused by that. Because like there's a limited vocabulary of tokens. You're telling me like the tokens are the links, or like it's not clear.
Yeah, what we meant by link prediction is that you are literally predicting, given some text, you are predicting the links that follow.
Yes.
That refers to it's how we describe the training procedure, which is that we find links on the web, we take the text surrounding the link, and then we predict which link follows. So you similar to transformers where you're trying to predict the next token. Here, you're trying to predict the next link. And so you kind of hide the link from the transformer. So if someone writes, imagine some article where someone says, hey, check out this really cool aerospace startup, and they say SpaceX.com afterwards. We hide the SpaceX.com and ask the model, what link came next.
Yeah.
And by doing that many, many times, billions of times, you could actually build a search engine out of that, because then at query time, at search time, you type in a query that's really cool aerospace startup, and the model will then try to predict what are the most likely links. So there's a lot of analogs to transformers, but to actually make this work, it does require a different architecture than but it's transformer inspired. Yeah.
What's the design decision between doing that versus extracting the link and the description and then embedding the description and then using
typical RAG?
What do you need to predict the URL versus just describing? Because you're kind of doing a similar thing in a way, right? It's kind of based on this description, what's the closest link for it. So one thing is predicting the link. The other approach is I extract the link and the description, and then based on the query, I search the closest description to it.
That by the way, that is the link refers here to a document. It's not. I think one confusing thing is you're not actually predicting the URL itself. That would require the system to have memorized URLs. You're actually getting the actual document. A more accurate name could be document prediction.
I see.
This was the initial base model that Exa was trained on, but we've moved beyond that. Similar to how to train a really good language model, you might start with this self-supervised objective of predicting the next token, and then just from random stuff on the web. But then you want to add a bunch of synthetic data and supervised fine-tuning stuff like that to make it really controllable and robust.
Yeah. We just have Flo from Lindy, and Lindy started to hallucinate Rickrolling YouTube links instead of a support guide. So
interesting.
Yeah.
So round about January, you announced your Series A and renamed to Exa. I didn't like the name at the initial, but it's grown on me. I liked Metaphor, but apparently people couldn't spell Metaphor. What would you say are the major components of Exa today, right? I feel like it used to be very model heavy. Then at the AI Engineer Conference, Shreyas gave a really good talk on the vector database that you guys have. What are the other major moving parts of Exa?
Okay, so Exa overall is a search engine, and we're trying to make it a perfect search engine. And to do that, you have to build lots of, and we're doing it from scratch, right? So to do that, you have to build lots of different subsystems. Yeah, you have to crawl a bunch of the web. First of all, you have to find the URLs to crawl. It's connected to the crawler, but you find URLs, you crawl those URLs, then you have to process them with some, it could be an embedding model, it could be something more complex, but you need to take, in the past, it was a keyword inverted index. You would process all these documents you gather into some processed index, and then you have to serve that at high throughput at low latency. And so that's the vector database. And so it's the crawling system, the AI processing system, and then the serving system. Those are all teams of hundreds, maybe thousands of people at Google. But for us, it's one or two people each typically. But yeah.
Can you explain the meaning of a Exa? Just a story 10 to the 16th and all that.
10 to the
18.
18.
Yeah, sure. So Exa means 10 to the 18th, which is in stark contrast to Google, which is 10 to the 100th. We actually have these awesome shirts that are 10 to the 18th is greater than 10 to the 100th.
Yeah, it's great.
And it's great because it's provocative. It's every engineer in Silicon Valley is what? No, it's not true. And then you ask them, okay, what does it actually mean? And the creative ones will recognize it. But yeah, I mean, 10 to the 18th is better than 10 to the 100th when it comes to search, because with search, you want the actual list of things that match what you're asking for. You don't want the whole web. You want to basically with search filter the everything that humanity has ever created to exactly what you want. And so the idea is smaller is better there. You want the best 10 to the 18th and not the 10 to the 100th. Like one way to say this is like, how Google often says at the top, 30 million results found. And it's like crazy because you're looking for like
the first
startups in San Francisco that work on hardware or something. And like, they're not 30 million results like that. What you want is like 325 results found. And those are all the results. That's what you really want with search. And that's our vision. It's like, it just gives you perfectly what you asked for.
We're recording this ahead of your launch. We haven't figured out the name of the launch yet. But what is the product that you're launching, I guess, now that we're coinciding this podcast with?
Yeah, so we've basically developed the next version of Exa, which is the ability to get a near perfect list of results of whatever you want. And what that means is you can make a complex query now to Exa, for example, startups working on hardware in SF, and then just get a huge list of all the things that match. And, our goal is if there are 325 startups that match that, we find you all of them. And this is just it's just like a new experience that's never existed before. It's really like, I don't know how you would go about that right now with current tools. And you could apply this same type of like technology to anything. Like let's say you want to find all the blog posts that talk about Zoox's podcast that have come out in the past year.
That is 30 million results.
Yeah. Look, I'm sure that would be extremely useful to you guys. And like, I don't really know how you would get that full comprehensive list.
There's so many questions with regards to how do you know it's complete, right? Because you're saying there's only 30 million or 325, whatever. And then how do you do the semantic understanding that it might take, right? So working in hardware, like I might not use the words hardware. I might use the words robotics. I might use the words wearables. I might use like whatever.
Yes.
So yeah, just tell us more.
Yeah, sure. So one aspect of this is a little subjective.
Yeah.
So like certainly providing, at some point we'll provide parameters to the user to like, some sort of threshold to like gauge like, okay, like this is a cutoff. Like this is actually not what I mean, because sometimes it's subjective and there needs to be a feedback loop. Like, oh, like it might give you like a few examples and you say
is this
like,
what you want?
Yeah, exactly. And so like you're kind of like creating a classifier on the fly, but like that's ultimately how you solve that problem. So there's a subjectivity problem, and then there's the comprehensiveness problem. Those are two different problems. So to solve the comprehensiveness problem, what you basically have to do is you have to put more compute into the query, into the search, until you get the full comprehensiveness.
Yeah.
And I think there's an interesting point here, which is that not all queries are made equal. Some queries, just like this blog post one, might require scanning, like scavenging, like throughout the whole web, in a way that just simply requires more compute. At some point, there's some amount of compute where you will just be comprehensive. You could imagine, for example, running GPT-4 over the entire web and saying, like, is this a blog post about Zoox's podcast? Like, is this a blog post about Zoox's podcast? And then that would work, right? It would take, a year, maybe cost like $1 million, or many more, but it would work. The point is that, like, given sufficient compute, you can solve the query. And so it's really a question of, like, how comprehensive do you want it given your compute budget? I think it's very similar to O1, by the way. And one way of thinking about what we built is like O1 for search, because O1 is all about like, some questions require more compute than others, and we'll put as much compute into the question as we need to solve it. So similarly with our search, we will put as much compute into the query in order to get comprehensiveness.
Yeah. Does that mean you have like some kind of compute budget that I can specify?
Yes.
Okay. And like, what are the upper and lower bounds?
Yeah, this is something we're still figuring out. I think like everyone, there's a new paradigm of like variable compute products.
Yeah.
How do you specify the amount of compute? Like what happens when you run out? Do you just like, can you like keep going with it? Like, do you just put in more credits to get more? For some, like this can get complex at like the really large compute queries. And like one thing we do is we give you a preview of what you're going to get. And then you could then spin up like a much larger job to get like way more results. But yes, there is some compute limit, at least right now.
Yeah.
People think of searches as like, oh, it takes 500 milliseconds because we've been conditioned to have search that takes 500 milliseconds by like search engines like Google, right? No matter how complex your query to Google, it will take like roughly 400 milliseconds. But what if searches can take like a minute or 10 minutes or a whole day? What can you then do? And you could do very powerful things. You can imagine writing a search, going to get a cup of coffee, coming back, and you have a perfect list. Like that's okay for a lot of use cases.
Yeah. I mean, the use case closest to me is venture capital, right? So, 8 years ago, I built one of the first like data-driven sourcing platforms. So we would look at GitHub, Twitter, Product Hunt, all these things, look at interesting things, evaluate them. If you think about some jobs that people have is like literally just make a list. If you're like an analyst at a venture firm, your job is to make a list of interesting companies and then you reach out to them. How do you think about being infrastructure versus like a product? You could say, hey, this is like a product to find companies. This is a product to find things versus like offering more as a blank canvas that people can build on top of.
Oh, right. We are a search infrastructure company, so we want people to build on top of us, build amazing products on top of us. But with this one, we tried to build something that makes it really easy for users to just log in, put some credits in, and just get like amazing results right away, and not have to wait to build some API integration. So we're kind of doing both. We want people to integrate this into all their applications. At the same time, we want to just make it really easy to use. Very similar again to OpenAI. Like they have an API, but they also have like a ChatGPT interface. So that it's really easy to use, but you could also build it in your applications.
Yeah. I'm still trying to wrap my head around a lot of the implications. So many businesses run on like information arbitrage, like I know this thing that you don't, especially in investment and financial services. So yeah, now all of a sudden you have these tools where like, oh, actually everybody can get the same information at the same time, the same quality level as an API call. It just kind of changes a lot of things.
Yeah, I think what we're grappling with here, what you're just thinking about is like, what is the world like if knowledge is kind of solved? If like any knowledge request you want is just like right there on your computer. It's kind of different from when intelligence is solved. There's like a I've written before about like a difference between
intelligence, super knowledge.
Yeah, like I think that the distinction between intelligence and knowledge is actually a pretty good one. They're definitely connected and related in all sorts of ways, but there is a distinction. You could have a world, and we are going to have this world, where you have like GPT-5 level systems and beyond that could like answer any complex request. Unless it requires some like, if you say like, give me a list of all the PhDs in New York City who, I don't know, have thought about search before. And even though this super intelligence is going to be like, I can't find it on Google, right? Which is kind of crazy. Like we're literally going to have like super intelligences that are using Google. And so if Google can't find them information, there's nothing they could do. They can't find it. But if you also have a super knowledge system where it's like, I'm calling this term super knowledge, where you can just get whatever knowledge you want, then you can pair it with a super intelligence system, and then the super intelligence will never be blocked by lack of knowledge.
Yeah, you told me this when we had lunch. I forget how it came up, but we were talking about AGI and whatnot, and you were like, even AGI is going to need search.
Yeah.
So
yeah, right.
Yeah. So we're actually referencing a blog post that you wrote, Super Intelligence and Super Knowledge. So I would refer people to that. And this is actually a discussion we've had on the podcast a couple of times. There's so much of model weights that are just memorizing facts. Some of those might be outdated. Some of them are incomplete or not. Yeah. So like you just need search and tool use. So I do wonder, like, is there a maximum language model size that will be the intelligence layer, and then the rest is just search, right? Like maybe we should just always use search, and then the sort of workhorse model is just like 1B or 3B parameter model that just drives everything.
Yes, I believe this is a much more optimal system to have a smaller LLM that's really just like an intelligence module, and it makes a call to a search tool. That's way more efficient because the opposite of that would be like the LLM is so big that it can memorize the whole web. That would be like way big, it's not practical at all. It's not possible to train that, at least right now. And Karpathy's actually written about this, how like he could see models moving more and more towards like intelligence modules using various tools.
Yeah. So for listeners, that was him on the No Priors podcast. And for us, we talked about this on the Shinyu and Harrison Chase podcast. I'm doing search in my head.
That's pretty cool. Right. Dude,
I told you, it's 30 million results.
I forgot about our Neuralink integration.
Self-hosted Exa.
No, I do see that is a much more efficient world.
Yeah.
I mean, you could also have GPT-4 level systems calling search, but it's just because of the cost of inference, it's just better to have a very efficient search tool and a very efficient LLM, and they're built for different things.
Yeah. I'm just kind of curious, like it is still something so audacious that I don't want to elide, which is you're building a search engine. Where do you start? How do you like, are there any reference papers or implementations that would really influence your thinking? Anything like that? Because I don't even know where to start apart from just crawl a bunch of shit. But there's got to be more insight than that.
I mean, yeah, there's more insight, but I'm always surprised by like if you have a group of people who are really focused on solving a problem with the tools today. Like there's so in software, like there are all sorts of creative solutions that just haven't been thought of before. Particularly in the information retrieval field. Yeah, I think a lot of the techniques are just very old, frankly. Like I know how Google and Bing work, and they're just not using new methods. There are all sorts of reasons for that. Like One, like Google has to be comprehensive over the web. So they have to return in 400 milliseconds. And those two things combined means they are kind of limited, and it can't cost too much. They're kind of limited in what kinds of algorithms they could even deploy at scale. So they end up using like a limited keyword-based algorithm. Also, like Google was built in a time where, like in 1998, where we didn't have LLMs, we didn't have embeddings, and so they never thought to build those things. And so now they have this like gigantic system that is built on old technology. And so a lot of the information retrieval field we found just like thinks in terms of that framework, whereas we came in as like newcomers, just thinking like, okay, here's GB3, it's magical. Obviously, we're going to build search that is using that technology, and we never even thought about using keywords. Really ever. We're neural all the way. We're building an end-to-end neural search engine. And just that whole framing just makes us ask different questions, like pursue different lines of work. And there's just a lot of low-hanging fruit because no one else is thinking about it. We're just on the frontier of neural search. We just are for at web scale because there's just not a lot of people thinking that way about it.
Yep. Maybe let's spell this out since we're already on this topic. Elephants in the room are Perplexity and SearchGPT. I think it's no longer called SearchGPT. I think they call it ChatGPT Search. How would you contrast your approaches to them based on what we know of how they work? And just anything in that area.
Yeah, so these systems, there are a few of them now. They basically rely on like traditional search engines like Google or Bing, and then they combine them with like LLMs at the end to, output some paragraph answering your question. So they like SearchGPT, Perplexity.
I think they have their own crawlers, no?
So there's this important distinction between like having your own search system and like having your own cache of the web.
Okay.
Like for example, so you could crawl a bunch of the web. Imagine you crawl 100 billion URLs, and then you create a key value store of like mapping from URL to the document. That is technically called an index, but it's not a search algorithm. So then to actually like, when you make a query to SearchGPT, for example, what is it actually doing? Let's say it's using the Bing API, getting a list of results, and then it could go. It has this cache of like all the contents of those results, and then could like bring in the cache, like the index cache. But it's not actually like it's not like they've built a search engine from scratch over hundreds of billions of pages. Like, is that distinction clear? It's like you could have like a mapping from URL to documents, but then rely on traditional search engines to actually get the list of results because it's a very hard problem to take. It's not hard to use DynamoDB and map URLs to documents. It's a very hard problem to take 100 billion or more documents and given a query, like instantly get the list of results that match. That's a much harder problem that very few entities on the planet have done. Like there's Google, there's Bing, there's Yandex, but there are not that many companies that are crazy enough to actually build their search engine from scratch when you could just use traditional search APIs.
So Google had PageRank as like the big thing. Is there a LLM equivalent or like any stuff that you're working on that you want to highlight?
The link prediction objective can be seen as like a neural PageRank because what you're doing is you're predicting the links people share. And so if everyone is sharing some Paul Graham essay about fundraising, then like our model is more likely to predict it. So like inherent in our training objective is this a sense of like high canonicity and like high quality. But it's more powerful than PageRank. It's strictly more powerful because people might refer to that Paul Graham fundraising essay in like 1,000 different ways. And so our model learns all the different ways that someone refers to that Paul Graham essay while also learning how important that Paul Graham essay is. So it's like PageRank on steroids kind of thing.
Yeah, I think to me that's the most interesting thing about search today, like with Google and whatnot. It's mostly like domain authority. So like if you get backlink, like if you search any AI term, you get this like SEO slop websites with like a bunch of things in them. So this is interesting. But then how do you think about more timeless maybe content? So if you think about, maybe the founder mode essay, right? It gets shared by like a lot of people, but then you might have a lot of other essays that are also good, but they just don't really get a lot of traction, even though maybe the people that share them are high quality. How do you kind of solve that thing when you don't have the people authority, so to speak, of who's sharing, whether or not they're worth kind of like bumping up?
Yeah, I mean, you do have a lot of control over the training data. So you could like make sure that the training data contains like high quality sources so that, okay, like if your training data, I mean, it's very similar to like language model training. Like if you train on like a bunch of crap, your prediction will be crap. Our model will match the training distribution it's trained on. And so we could like, there are lots of ways to tweak the training data to refer to high quality content that we want. Yeah, I would say also this slop that is returned by traditional search engines like Google and Bing, you have the slop is then transferred into these LLMs in like a SearchGPT or or other systems like that. Like if slop comes in, slop will go out. And so yeah, that's another answer to how we're different is like we're not like traditional search engines. We want to give like the highest quality results and like have full control over whatever you want. If you don't want slop, you get that. And then if you put an LLM on top of that, which our customers do, then you just get higher quality results or high quality output.
And I use ExaSearch very often, and it's very good.
Especially Brightwave uses it too.
Yeah. Like the slop is everywhere, especially when it comes to AI, when it comes to investment, when it comes to all of these things where like it's valuable to be at the top.
And this problem's only going to get worse because
totally. What else is in the toolkit? So you have Search API, you have ExaSearch, kind of like the web version. Now you have the list builder. I think you also have web scraping. Maybe just touch on that. I guess maybe people, they want to search and then they want to scrape, right? So is that kind of the use case that people have?
Yeah, a lot of our customers, they don't just want, because they're building AI applications on top of Exa, they don't just want a list of URLs. They actually want like the full content, like cleaned, parsed,
markdown,
maybe chunked, whatever they want, we'll give it to them. And so that's been like huge for customers, just like getting the URLs and instantly getting the content for each URL is like, and you can do this for 10 or 100 or 1,000 URLs, whatever you want. That's very powerful.
Yeah, I think this is the first thing I asked you for when I tried using Exa.
Yeah. Funny story is like when I built the first version of Exa, is like we just happened to store the content.
Yes.
Like the first 1,024 tokens, because I just kind of like kept it because I thought, I don't know why, really for debugging purposes. And so then when people started asking for content, it was actually pretty easy to serve it.
Yeah.
But then we did that, like Exa took off. So because content was so useful. So that was kind of cool.
It is. I would say there are other players like Gina, I think is in this space. Firecrawl is in this space. There's a bunch of scraper companies. And obviously Scraper is just one part of your stack, but like you might as well offer it since you already do it.
Yeah, it makes sense to have, it's just easy to have an all-in-one solution. And like we are, building the best scraper in the world. So scraping is a hard problem, and it's easy to get like, a good scraper. It's very hard to get a great scraper, and it's super hard to get a perfect scraper. So like, and scraping really matters to people.
Do you have a perfect scraper?
Not yet.
Okay,
but we're building.
The web is increasingly closing to the bots and the scrapers. Twitter, Reddit, Quora, Stack Overflow, I don't know what else. How are you dealing with that? How are you navigating those things? Like, OpenAI is like just paying them money.
Yeah, no, I mean, I think it definitely makes it harder for search engines. One response is just that there's so much value in the long tail of sites that are open.
Okay.
And just like, even just searching over those well gets you most of the value. But I mean, there is definitely a lot of content that is increasingly not unavailable. And so you could get through that through data partnerships. The bigger we get as a company, the easier it is to just like make partnerships. But I do see the world as like the future where the data producers, the content creators will make partnerships with the entities that find that data.
Any other fun use case that maybe people are not thinking about?
Yeah. Oh, I mean, there are so many.
Your customers. Yeah.
Yeah. What are people doing on Exa?
Well, I think dating is a really interesting application of search that is completely underserved because there's a lot of profiles on the web and a lot of people who want to find love. And
I'll use it. Give me like,
maybe this file just keeps myself.
Age boundaries, education level, location.
Right. Yeah. I mean, you want to, what do you want to do with dating? You want to find like a partner who matches this education level, who like, maybe has written about these types of topics before. Like, if you could get a list of all the people like that, like I think you will unblock a lot of people. I think this is a very Silicon Valley view of dating for sure, and I'm well aware of that. But it's just an interesting application of like, I would love to meet like an intellectual partner who like shares a lot of my ideas, and if you could do that through better search. Yeah.
For what it's worth, Jeff has already sent me up with a few people. So like Jeff, I think is my personal Exa for dating.
Right. My mom's actually a matchmaker and has gotten a lot of people married. Yeah.
No kidding.
Yeah. Search is built into the book.
It's in your genes.
Yeah.
Other than dating, like I know you're having quite some success in colleges. I would just love to map out some more use cases so that our listeners can just use those examples to think about use cases for Exa, right? Because it's such a general technology that it's hard to really pin down like what should I use it for and what kind of products can I build with it.
Yeah, sure. So, I mean, there are so many applications of Exa, and we have, many companies using us for a very diverse range of use cases, but I'll just highlight some interesting ones. Like one customer, a big customer is using us to basically build like a writing assistant for students who want to write research papers. And basically like Exa will search for like a list of research papers related to what the student is writing. And then this product has like an LLM that like summarizes the papers to basically it's like a next word prediction, but prompted by 20 research papers that X has returned.
It's like literally just doing their homework for them.
Yeah, I guess. But the key point is research is a really hard thing to do, and you need high quality content as input.
Oh, so we've had Illicit on the podcast. I think it's pretty similar.
Okay.
They do focus pretty much on just research papers and that research use case. Basically, I think dating research. I just wanted to spell out more things, just the big verticals.
Yeah. No, I mean there are so many use cases. So
finance, we talked about.
Yeah, I mean one big vertical is just finding a list of companies. So it's useful for VCs, like you said, who want to find a list of competitors to a specific company they're investigating, or just a list of companies in some field. There was one VC that told me that him and his team were using Exa for 8 hours straight, for many days on end, just doing lots of different queries of different types, all the companies in AI for law, or all the companies for AI for construction, and just getting lists of things, because you just can't find this information with traditional search engines. And then finding companies is also useful for selling. If you want to find, if we want to find a list of writing assistants to sell to, then we just use Exa ourselves to find. That's actually how we found a lot of our customers.
Ooh, you can find your own customers using Exa. Oh my God!
In the spirit of using Exa to bolster Exa, recruiting is really helpful. Is a really great use case of Exa, because we can just get a list of people who've thought about search, and just get a long list, and then reach out to those people.
When you say thought about, are you thinking LinkedIn, Twitter, or are you thinking just blogs?
Or they've written. I mean, it's pretty general. So in that case, ideally, Exa would return the really blogs written by people who have just.
So if I don't blog, I don't show up to Exa, right? I have to blog.
Well, I mean, you could show
an incentive for people to blog.
Well, if you've written about search on Twitter, and we do index a bunch of tweets, and then we should be able to service that.
Yeah. I mean, this is something I tell people, you have to make yourself discoverable to the web. It's called learning in public, but it's even more imperative now.
Yes.
Otherwise, you don't exist at all.
Yeah. No, this is a huge thing, which is search engines completely influence. They have downstream effects. They influence the internet itself. They influence what people choose to create. And so Google, because they're a keyword-based search engine, people
keyword stuff.
Yeah, they're incentivized to create things that just match a lot of keywords, which is not very high quality. Whereas Exa is a search algorithm that optimizes for high quality and actually matching what you mean. And so people are incentivized to create content that is high quality, that they create content that they know will be found by the right person. So if I am a search researcher and I want to be found by Exa, I should blog about search and all the things I'm building, because now we have a search engine like Exa that's powerful enough to find them. And so the search engine will influence the downstream internet in all sorts of amazing ways. Yeah. Whatever the search engine optimizes for is what the internet looks like.
Yeah. Are you familiar with the term McLuhanism?
No, what's that?
It's this concept that first we shape tools and then the tools shape us.
Okay, yeah.
So there's this reflexive connection between the things we search for and the things that get searched.
Yes.
So once you change the tool that searches, the things that get searched also change.
Yes. I mean, there was a clear example of that.
With 30 years of Google.
Yeah, exactly. Google has basically trained us to think of search. Google is search, in people's heads, right?
Yeah.
One hard part about Exa is ripping people away from that notion of search and expanding their sense of what search could be. Because when people think search, they think a few keywords, or at least they used to. They think of a few keywords and that's it. They don't think to make these really complex paragraph long requests for information and get a perfect list. ChatGPT was an interesting thing that expanded people's understanding of search, because you start using ChatGPT for a few hours and you go back to Google and you paste in your code and Google just doesn't work, and you're oh wait, Google doesn't work that way. So ChatGPT expanded our understanding of what search can be, and I think Exa is part of that. We want to expand people's notion hey, you could actually get whatever you want.
Yeah.
I search on Exa right now, people writing about learning in public. I was is it gonna come up with Wix? You're not, because it's so it's so about because it thinks about learning in public, public schools, and focuses more on that. It's how when there are these highly overlapping things, this is a good result based on the query, but how do I get to Wix, right? So if you're in these subcultures, I don't think this would work in Google well either, but I don't know if you have any learnings.
No, I'm the first result on Google.
People writing about learning in public. you're not first result anymore, I guess.
Just type learn in public in Google.
Well, yeah. But this is also like, this is in Google, it doesn't work either. That's what I'm saying. It's like how, when you have like a movement.
There's confusion about the, like what you mean, like your intention is a little.
It's like I'm using a term that like I didn't invent, but I'm kind of taking over.
Yeah.
But like there's just so much about that term already that it's hard to overcome. If that makes sense, because public schools is like, well, it's hard to overcome public schools, you know.
Yeah. So there's the right solution to this, which is to specify more clearly what you mean. And I'm not expecting you to do that, but so the right interface to search is actually an LLM. Like you should be talking to an LLM about what you want, and the LLM translates its knowledge of you or knowledge of what people usually mean into a query that Exa then uses.
Which you have called auto prompts, right? Or
yeah, but it's like a very light version of that. And really, it's just basically the right answer is it's the wrong interface. And like very soon the interface to search and really to everything will be LLMs. And the LLM just has a full knowledge of you, right? So we're kind of building for that world. We're skating to where the puck is going to be. And so since we're moving to a world where like LLMs are interfaced to everything, you should build a search engine that can handle complex LLM queries that come from LLMs. Because you're probably too lazy, and I'm too lazy too, to write like a whole paragraph explaining, okay, this is what I mean by this word. But an LLM is not lazy. And so like the LLM will spit out like a paragraph or more explaining exactly what it wants. You need a search engine that can handle that. Traditional search engines like Google or Bing, they're actually designed for humans typing keywords. If you give a paragraph to Google or Bing, they just completely fail. And so Exa can handle paragraphs, and we want to be able to handle it more and more until it's like perfect.
What about opinions? Do you have lists? When you think about the list product, do you think about just finding entries? Do you think about ranking entries? I'll give you a dumb example, right? So on Lindy, I've been building this bot that every week gives me like the top fantasy football waiver pickups. Okay. But every website is like different opinions. I'm like, you should pick up these 5 players, these 5 players. When you're making lists, do you want to be kind of like also ranking and like telling people what's best, or like are you mostly focused on just surfacing information?
There's a really good distinction between filtering to like things that match your query and then ranking based on like what is like your preferences. And ranking is like filtering is objective. It's like does this document match what you asked for? Whereas ranking is more subjective. It's like what is the best? Well, it depends what you mean by best, right? So first table stakes is let's get the filtering into a perfect place where you actually like every document matches what you asked for. No search engine can do that today. And then ranking, there are all sorts of interesting ways to do that, where like you've maybe have the user like specify more clearly what they mean by best. You could do, if the user doesn't specify it, you do your best. You do your best based on what people typically mean by best. But ideally, like the user can specify, when I mean best, I actually mean ranked by the number of people who visited that site, let's say, is one example ranking. Or, what I mean by best, let's say you're listing companies. What I mean by best is like the ones that have the most employees or something like that. Like there are all sorts of ways to rank a list of results that are not captured by something as subjective as best.
Yeah. I mean, it's like, who are the best NBA players in the history? It's like everybody has their own.
Right. But I mean, the search engine should definitely, like, even if you don't specify it, it should do as good of a job as possible.
No, totally. Yeah.
It's a new topic to people because we're not used to a search engine that can handle like a very complex ranking system. Like you think to type in best basketball players and not something more specific because that's the only thing Google could handle. But if Google could handle like, basketball players ranked by like number of shots scored on average per game, then you would do that. But they can't do that. So
yeah, that's fascinating. So you haven't used the word agents, but you're kind of building a search agent. Do you believe that is agentic in feature? Do you think that term is distracting?
I think it's a good term. I do think everything will eventually become agentic. And so then the term will lose power. Yeah. But yes, like what we're building is agentic. It, in the sense that it takes actions, it decides when to go deeper into something. It has a loop, right? It feels different from traditional search, which is like an algorithm, not an agent. Ours is a combination of an algorithm and an agent.
I think my reflection from seeing this in the coding space, where there's basically sort of classic framework for thinking about this stuff is the self-driving levels of autonomy, right? Level 1 to 5. Typically, the level 5 ones all failed because they're full autonomy and we're not there yet. And people like control. People like to be in the loop. So the level 1s was Copilot first, and now it's like Cursor and whatever. So I feel like if it's too agentic, it's too magical, like a one shot. I stick a paragraph into the text box and then it spits it back to me. It might feel like I'm too disconnected from the process and I don't trust it. as opposed to something where I'm more intimately involved with the research product.
I see. So like, wait, so the earlier versions are...
So if trying to stick to the example of the basketball thing, like best basketball player, but instead of best, you actually get to customize it with like whatever the metric is that you guys care about. Yeah, I'm still not a basketballer.
Yeah, me neither.
but you know, people like to be in, my thesis is that level 5 agents failed because people like to kind of have drive assist rather than full self-driving.
I mean, a lot of this has to do with how good agents are. Like at some point, if agents for coding are better than humans at all tasks, then
sure.
Humans
we're not
block.
There yet.
Yeah, we're not there yet. So like in a world where we're not there yet,
what you're pitching us is like you're kind of saying you're going all the way there. Like I think O1 is also very full self-driving. You don't get to see the plan. You don't get to affect the plan. You just fire off a query and then it goes away for a couple minutes and comes back, right? Which is effectively what you're saying you're going to do too.
And you think there's an
in-between.
So in building this product, we're exploring new interfaces because what does it mean to like kick off a search that takes 10 minutes? Like, is that a good interface? Because what if the search is actually wrong, like, or it's not exactly specified to what you mean?
Which is why you get previews.
Yeah, you get previews. So it is iterative. But ultimately, once you've specified exactly what you mean, then you kind of do just want to kick off a batch job, right?
Yeah.
So perhaps what you're getting at is like, there's this barrier with agents where you have to like explain the full context of what you mean, and a lot of failure modes happen when you don't.
Yeah.
There's failure modes from the agent just not being smart enough, and then there's failure modes from the agent not understanding exactly what you mean. And there's a lot of context that is shared between humans that is like lost between like humans and this like new creature.
Yeah, because people don't know what's going on. I mean, to me, the best example of like system prompts is like, why are you writing you're a helpful assistant? Like, of course you should be an helpful assistant, right. But people don't yet know, like, can I assume that you know that? You know, it's like, why did and now people write, oh, you're a very smart software engineer. Or like, you never make, you never make mistakes. Like, were you going to try and make mistakes before? So I think people don't yet have an understanding. Like with driving, people know what good driving is. It's like, don't crash, stay within kind of like a certain speed range. It's like, follow the directions. It's like, I don't really have to explain all of those things, I hope. But with AI and like models and like search, people are like, okay, what do you actually know? What are like your assumptions about how you're going to do search? And like, can I trust it? You know, can I influence it? So I think that's kind of the middle ground. Like before you go ahead and like do all the search, it's like, can I see how you're doing it? And then maybe help
show
you
your work.
Kind of like, steer you.
Yeah. No, I mean, yeah, you're saying even if you've crafted a great system prompt, you want to be part of the process itself. Because the system prompt doesn't capture everything, right?
Yeah.
So yeah, a system prompt is like you get to choose the person you work with. It's like, oh, like I want a software engineer who thinks this way about code. But then even once you've chosen that person, you can't just give them a high level command and they go do it perfectly. You have to be part of that process. So yeah, I agree.
Just a side note, for my favorite system prompt programming anecdote now is the Apple Intelligence system prompt. Someone's prompt injected it and seen it, and like the Apple Intelligence has the words like, please don't hallucinate. And it's like, of course we don't want you to hallucinate, right? Like, so it's exactly that what you're talking about. Like, we should train this behavior into the model, but somehow we still feel the need to inject it into the prompt. And I still don't even think that we're very scientific about it. Like, I think it's almost like cargo culting. Like, we have this like magical, like, turn around 3 times, throw salt over your shoulder before you do something. And like, it worked the last time, so let's just do it at the same time now. And like, there's no science to this.
I do think a lot of these problems might be ironed out in future versions, right? Yeah. So, and like, they might hide the details from you. So it's like all of them have a system prompt that's like, you are a helpful assistant. You don't actually have to include it, even though it might actually be the way they've implemented it in the backend.
Yeah, it should be done in RLAF. Okay, one question I'm just kind of curious about. This episode is, I'm going to try to frame this in terms of just the general AI search wars. Mm-hmm. You know, you're one player in that. There's Perplexity, ChatGPT search, and Google. But there's also like the B2B side. We had Drew Houston from Dropbox on, and he's competing with Glean, we've also had Didi from Glean on. Is there appetite for Exa for my company's documents?
There is appetite, but I think we have to be disciplined. I mean, we're already taking on like perfect web search, which is a lot. But I mean, ultimately, we want to build a perfect search engine, which definitely, for a lot of queries, involves your personal information, your company's information. And so, yeah, I mean, the grandest vision of Exa is perfect search really over everything.
Every domain.
You know, we're going to have an Exa satellite because because satellites can gather information that is not available publicly.
Gotcha.
Yeah.
Can we talk about AGI?
Yeah, of course.
We never talk about AGI, but you had this whole tweet about O1 being the biggest kind of like AI step function towards it. Why does it feel so important to you? I know there's kind of like always criticism and saying, hey, it's not that smart, Sun is better. It's like blah, blah, blah. What did you see? So you say this is what Ilya see, what Sam see, what they will see.
I've just been connecting the dots. I mean, this was the key thing that a bunch of labs were working on, which is like, can you create a reward signal? Can you teach yourself based on a reward signal? If you're trying to learn coding or math, if you could have one model say, be a grading system that says like, you have successfully solved this programming assessment, and then one model like be the generative system that's like, here are a bunch of programming assessments. You could train on that. So basically, whenever you could create a reward signal for some task, you could just generate a bunch of tasks for yourself, see that like, oh, on 2 of these 1,000, you did well, and then you just train on that data. It's basically, creating your own data for yourself. And like, all the labs working on that, OpenAI built the most impressive product doing that. And it's just it's very easy now to see how that could like scale to just solving like solving programming or solving mathematics, which sounds crazy, but everything about our world right now is crazy. And so I think if you remove that whole like, oh, it's impossible, and you just think really clearly about like what's now possible with like what they've done with O1, it's easy to see how that scales. How
do you think about older GPT models then? Should people still work on them? If like, obviously they just had the new Haiku, like, is it even worth spending time like making these models better versus just, Sam talked about O2 at that day. So obviously they're spending a lot of time in it, but then you have maybe the GPU poor, which are still working on making Llama good. And then you have the follower labs that do not have an O1 like model out yet. Yeah, this kind of gets into like, what will the ecosystem of models be like in the future? And is there room, is everything just going to be O1 like models? I think, there's definitely a question of like inference speed, and if certain thing like O1 takes a long time because that's the think. Well, O1 is 2 things. It's like one, it's bootstrapping itself, it's teaching itself, and so the base model is smarter. But then it also has this like inference time compute where it could like spend like many minutes or many hours thinking. And so even the base model, which is also fast, it doesn't have to take minutes. It could take is better, smarter. I believe all models will be trained with this paradigm. Like you'll want to train on the best data, but there will be many different size models from many different like companies, I believe. Yeah, because like it's hard to predict, but I don't think OpenAI is going to dominate like every possible LLM for every possible use case. I think for a lot of things, like you just want the fastest model, and that might not involve O1 methods at all.
I would say if you were to take the Exa being O1 for search literally, you really need to prioritize search trajectories, like almost maybe paying a bunch of grad students to go research things, and then you kind of track what they search and what the sequence of searching is. Because it seems like that is the gold mine here, like the chain of thought or the thinking trajectory. Yeah, when it comes to search, I've always been skeptical of human labeled data. Okay. Yeah, please.
We tried something at our company at Exa recently where me and a bunch of engineers on the team like labeled a bunch of queries, and it was really hard. Like you have all these niche queries, and you're looking at a bunch of results, and you're trying to identify like, which is matched to query. Like it's talking about the intricacies of like some biological experiment or something. I have no idea. Like I don't know what matches. And what labelers like me tend to do is just match by keyword. I'm like, oh, like this document matches a bunch of keywords, so it must be good. But then you're actually completely missing the meaning of the document. Whereas an LLM like GPT-4 is really good at labeling. And so I actually think like we get by, which we are right now doing, using like LLMs as the labelers. Specifically for search, I think it's interesting. It's different between like search and like GPT-5 are different because GPT-5 might benefit from training on a lot of PhD notes because like GPT-5 might have to do like very, very complex like problem solving when it's given an input. But with search, it's actually a very different problem. You're asking simple questions about billions of things. So like whereas like GPT-5 is asking it's like solving a really hard question, but it's like one question, a PhD level question. With search, you're asking like simple questions about billions of things like, is this a startup? Did this person write a blog post about search? Those are actually simple questions. You don't need like PhD level training data. Does that make sense?
Yeah.
What else we got here? Nap pods.
Oh yeah.
So like just generally, I think Exa has a very interesting company building vibe. Like you have a meme lord CTO. I guess.
Yeah, I guess.
I don't know. Like, and you just generally are counter consensus in a bunch of things. What is the culture at Exa like?
Yeah, me and Jeff are. I mean, we've been best friends since like we met first day of college, and we've been best friends ever since. And we have a really good vibe. I think that's like intense, but also really fun and like funny. Honestly, we have a ton of we just laugh a ton at Exa, and I think that's just like you see that in every part of our culture. We don't really care about how the world sees anything. Like me and Jeff are just like that. Like we're just thinking really just like what should we do here? Like what do we need? And so in the NapPod case, it was like people get tired a lot when they're coding or doing anything really, and like why can't we just sleep here or like nap? And okay, if we need a nap, then we should get a nap pod. It's crazy to me that there aren't nap pods in lots of companies because like I get tired all the time. I take a nap like every other day probably for like 20 minutes. I'm actually never actually napping. I'm just thinking about a problem, but closing my eyes really like, first of all, it makes me come up with more creative solutions, and then also actually gives me some rest. So it's just
Google
awesome.
was the original company that had the nap pods at work, right?
Oh, okay. Well, at one point, Google was thinking from first principles on everything too, and that was reflected in their
But also,
nap pods.
you didn't just get a nap pod for your office. You like found something from China, and you're like, who wants to get in on this? Let's get a container full of them.
Yeah, well, we try to be frugal. So like we were looking at like different nap pods, and then at some point we were like, wait, China probably has solved this problem, and so then we ordered it from China, and then it was actually so heavy. Like when it came off the truck, it was like 500 pounds, and the truck was like having trouble like putting it on the ground, and so like me and the delivery guy were like trying to hold it, and then we couldn't. We were struggling. So someone came out from the street and like started helping us.
You hurt yourself, man.
I know it was really dangerous, but we did it, and then it was awesome. And
it's funny. I was reading the TechCrunch article about it.
There was a TechCrunch article on the nap pods?
Yeah. And then Jeff explained, well, they quote Jeff. And this paragraph says, so the nap pods maintain employees' ability to stop work and sleep rather than the idea that, in quotes, employees are slaves. Close quote. I don't know.
Jeff has a way with words.
What? I'm sure that's not what he meant. But I'm curious, like, just like how people, there's always like this, I think for a little bit it went away about like startups and kind of like hustle culture and like all of that. And I think now with AI, people are like, have all these feelings towards AI that are kind of like.
I think guys are pro hustle culture, right?
Yeah, but I mean, ideally the hustle is like, people are just having fun, which is people are just having fun.
Yeah, but I would say from the outside, it's like people don't like it. I'm saying people not in AI and kind of like in tech, they're kind of like, oh, these guys are at it again. These are like the same people that gave us underpaid drivers or like whatever. It's like, so it was just funny to see. Somehow they wanted to make it sound like Jeff was saying employees are slaves, but like,
I don't know.
That doesn't make sense.
But yeah, I mean, okay, I can't imagine a more exciting experience than like building something from scratch that's like a huge deal with a bunch of your friends. Our team is going to look back in 10 years and think this was like the most beautiful experience that you could have in life, and like that's how I think about it. And that's just so it's not hustle or not. It's like, is this like does this satisfy like your core desire to like build things in the world? And it does.
Yep. Yeah. Anything else we didn't cover? Any parting thoughts? Are you hiring? Obviously you're looking for more people to use it, but
yeah, we're definitely hiring. We're growing quite fast, and we have a really smart team of engineers and researchers. And we now have, we just purchased a $5 million H200 cluster. So we have a lot more compute to play with.
Do you run all your own inference?
We do a mix of our cluster and like AWS. Inference, we use these, so we have our current cluster, which is like A100s, and now we've updated to a new one. We use it for training and research.
What's the training versus inference budget? Like, is it like is it 50-50? Is it?
Yeah, there will be more inference for search for sure.
The other thing I mentioned, so by the way, I'm like sidetracking, but I'm just kind of throwing this in there because I always think about the economics of AI search. Like for those, I think if you look up, there's the upper limit is going to be whatever you can monetize off of ads, right? So for Google, let's say it's like 1 cent per 1,000 views, something like that. I don't know the exact number. The exact number is floating around out there. That means that's your revenue, right? Then your cost has to be lower than that. And so at some point, like for an LLM inference call to be made for every page view, you need to get it lower than the money that you take in for that. And like one of the things that I was very surprised for Perplexity and Character as well was that they couldn't get it so low that it would be reasonable. I think for you guys, it is a mix of front loading it by indexing. So you only run that compute like once a month, once a quarter, whatever you do reindexing, and then it's just a little bit more when you do inference, when the search actually gets done, right? Like, so I think when people work out like the economics of such a business, they have to kind of think about where do you put the costs.
Yes. I mean, definitely you cannot run LLMs over the whole index, billions of things at query time. So you have to pre-process things, usually with LLMs. But then you can do a re-rank over like, 10, 30, 100, depending on 1,000, depending on how, you could play with different sizes of transformers to get the cost to work out. I mean, one really interesting thing is like we're building a search engine at a time where LLM costs are going down like crazy. When some very useful tool goes down in cost by 200x in like the space of a couple of years, there are going to be new opportunities in search, right? So like to not integrate this and to not like rethink search from scratch, the search algorithm itself, given the fact that things are going down 200x is crazy.
Thank you so much for coming on, man. It was fun.
Thank you. This was so fun. Really fun.